everyone, welcome to Apurva'S mathematics class. In today's class we will be learning engineering concept, that is integral calculus. In integral calculus we will be concentrating on beta and gamma functions. So where do we use this beta and gamma functions? Beta and gamma functions, basically I can say that if we are having some integration problem, if we can't solve that problem, at that case if it is a definite integral, then we will be using this beta and gamma function formula to solve our definite integral problems, because it will be easy to solve using this particular beta and gamma functions formula. And where it has been used, it has been widely used in physics, statistics and machine learning, so on. So how it has been used? Machine learning, for predictions it will be used, beta and gamma functions will be used for predictions, and in fluid mechanics for considering out the value, for predicting the next values, that we will be using this beta and gamma functions in fluid mechanics. And in medicine cases also they will be using. Why? Because to predict out the drug. So minimum mathematical aspect is required, right? So where there all we use this beta and gamma functions. Fine. So concentrating on the beta and gamma function mathematical part, this beta and gamma function is generally used if there is no other possible way in integration. We will be using this beta and gamma function formula to find out the answers for our particular definite integral problem. So let us consider the definition for the beta function and the gamma function first. So beta function is given by, before defining beta function I will give the notation by which beta function is being defined. So beta function is being defined by the notation considered as beta function. I am writing here beta function. Beta function is defined by the notation beta. This is how we will be defining. So beta function it will be having two variables, that is m comma n. So beta function is defined as beta of m comma n, and the formula is being given as, since I told it already, this is definite integral. So this will be having limits. So 0 to 1 x to the power m minus 1 times of 1 minus ex to the power n minus 1 dx. And this is true. This n value will be mn value. Here this mn value will be greater than 0. Always remember, mn value will be positive. And here this is the formula of beta function. Beta function of m comma n is given by definite integral of from 0 to 1 x to the power m minus 1 times of 1 minus x whole to the power n minus 1 dx. This is how we define. This is considered as a beta function. So next let me talk about the gamma function. What is the formula for the gamma function? Gamma function is defined as, gamma function is being defined by the notation. Initially I will say you the notation. Gamma function is defined by the notation gamma of n. This is how we will be considering gamma function. Gamma of n is given by integral 0 to infinity e power minus x into x to the power n minus 1 dx. And here we have only one variable, that is n, right? So n will be always positive, that is n is greater than 0. So our gamma function is defined as gamma of n is equals to integral from 0 to infinity. So here it is a definite integral, and here also it is a definite integral, but the range is wide here in the gamma function compared to the beta function. So it takes the values from 0 to infinity e power minus x times of x to the power n minus 1 dx, and this n value will be positive. This won't be negative. This is an entity. Therefore, we will be considering a positive value. Clear? We also represent this beta gamma functions in terms of sine and cos. So let me consider that formula as well. So for our beta function, let me write the beta function here. Alternative forms. I'll consider this as the alternative forms. Alternative forms of what? Beta and gamma function. So let me write the beta function first. I am considering the beta function. And considering the alternate form of beta function. Now how do we represent this beta function in the alternate form? Beta of m comma n is equals to integral 0 to pi by 2 sine to the power 2n minus 1 theta into cos to the power 2n minus 1 theta d theta. And this is twice here, remember, don't forget this, twice of integral 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power 2n minus 1 theta d theta. And again, this gamma function, let me write the alternative form of this gamma function as well. Gamma function is defined by gamma of n is given by twice integral 0 to infinity e power minus x square into x to the power 2n minus 1 dx. X to the power 2n minus 1 dx. So using this formula, we will be solving out some problems here. I have not taken the proof here. Proof you will be getting in a different video. Using this formulas, we will solve out few problems in this particular video. And let me say you, before going to the concept, before solving out some problems, I'll give some properties of this beta functions and gamma functions also. So let me take the property here. Properties. I'm considering the properties of beta and gamma function. Let me consider the first property here. First property says beta of m comma n. If I interchange this m and n value, even then my beta value will be retained as it is, will be same. So m comma n and n comma m doesn't matter. So beta of m comma n is equals to beta of n comma m. Then the next property is gamma of n plus 1 is given by n times of gamma of n. Gamma of n plus 1 can be considered as n times of gamma of n times of gamma of n. So this one I can take it in one more format. So have a look here, have a keen observation here. Gamma of n can be written as gamma of n minus 1 times of n minus 1. If and only if gamma is not equal to 1. You remember this, gamma of n can also be considered as gamma of n minus 1 times of gamma n minus 1 when n is not equal to 1. When n is not equal to 1. We will consider two more formulas here. The next formula here is given by gamma of n plus 1 is considered as n factorial. Gamma of n plus 1 is considered as n factorial only if n is positive. If and only if n is positive, then only we can consider positive integer. It should be positive integer. Only then we can say that gamma of n plus 1 is equals to n factorial. We will use all these properties and this formula in our sums to solve out, so that you will get to know how do we use all these things at what time. Clear? Next, the last formula which I am considering here under the properties is fourth formula, that is gamma of n is given by n minus 1 factorial. Then this is considered when n is positive. N is greater than 1, n is positive. This is considered when n is positive. And next, gamma of n is given by gamma of n plus 1 divided by n when n is negative, that is n is less than 1. Here, look at here, gamma of n plus 1 is given by n times of gamma of n, right? So I can consider this as, here move this n towards that side, so it becomes gamma of n divided by n. That is what is given by here. So this fourth property says gamma of n is given by n minus 1 the whole factorial, which is when n is positive. If the n is negative, at that case we will be considering this formula. So if n value is positive, we will be considering this formula for gamma of n. If n is negative, we will be considering this property for this particular problem. Clear? Now we will consider the relationship between the gamma and beta function. Relationship between beta and gamma functions. Relationships between beta and gamma functions. The formula is given by beta of m comma n is given by gamma of m times of gamma of n divided by gamma of m plus n. Beta of m comma n is given by gamma of m into, this is into over here, into gamma of n whole divided by gamma of m plus n. Gamma of m plus n. This is the relationship between beta and gamma function. Clear? Hope it is clear. These are the formulas we will be using for our proofs. Clear? Next. So now we have considered one of the important proof, that is gamma of 1 by 2 is given by root pi. This one we will be considering it as a property. This is one of the most important proof which will be asked in exam frequently. Okay, so we will learn how to prove this out. So to prove this, we need the relationship between the gamma and the beta function. So what is the relationship between the gamma and the beta function? Just now we have learned the relationship between the beta and the gamma function, that is given by beta of m comma n times of gamma of n into gamma of n whole divided by gamma of m plus n. So we will take this formula here and we will start proving this property. Okay, so we have to first take out the relationship between beta and the gamma function. It is given by, I'm starting my proof here. The proof is starting as proof. I'm considering the proof here. So what we are considering? We are considering the relationship now. Correct. So let us consider that we know that the relationship between the beta and the gamma function is given by beta of m comma n is given by gamma of m into gamma of, you consider in the brackets, okay, the gamma of m into gamma of n whole divided by gamma of m plus n, gamma of m plus n. And what is the value they have given us here? They have given us 1 divided by 2. So I'll consider here m is equals to, n is equals to 1 by 2. Since they have given here gamma of 1 by 2, I'll take by both m and n values as 1 by 2 here. Clear? So I'm substituting this in this formula relationship. So what does it become? Beta of 1 by 2 comma 1 by 2 is equals to gamma of 1 by 2 into gamma of 1 by 2. This is multiplication here. Remember, gamma of 1 by 2 plus 1 by 2. So what does this goes? 1 by 2 plus 1 by 2. Half plus half is 1. So we will correct it over here. Gamma of 1 by 2 into gamma of 1 by 2 whole divided by gamma of 1. We know that just from the property, we know that gamma of 1 is given by 1. Gamma of 1 is given by 1. So I'll write it here. Gamma of 1 is equals to 1. Gamma of 1 is equals to 1. Clear? So how did we consider this gamma of 1? Gamma of 1, we know that since gamma of 1 is equals to 1, in the next step I will just consider this as beta of 1 by 2 comma 1 by 2 can be written as this is 1 and this is 1, and here we have multiplication, so this becomes square. So gamma of 1 by 2 the whole square divided by 1, which we can write it as beta of 1 by 2 comma 1 by 2 is given by gamma of 1 by 2 the whole square. I will consider this as equation number 1. Equation number 1. I will consider this as equation number 1. Done. Next. So here in the next step I'll consider one more property. What is the alternative formula of this beta function? Alternate property of the beta function is given by 2 times of 0 to pi by 2 sine 2 to the power 2m minus 1 theta cos 2n minus 1 theta d theta. We will consider this formula. Okay, so our alternative formula is given by, I'll write it this in pink color pen. Our rule is given by, alternate rule, beta of m comma n can be considered as 2 times of integral 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power of 2n minus 1 theta d theta. So what is our m we have considered here? We have considered our m and n both equal to 1 by 2. Correct. So now I will substitute this m and n here. So what does it becomes? This becomes, look at here, I am substituting m is equals to 1 by 2 and b is equals to 1 by 2 here. 1 by 2 comma 1 by 2. So this becomes 2 times of integral 0 to pi by 2, integral 0 to pi by 2 sine. In the position of m here I am substituting 1 by 2 minus 1 theta into cos 2 into, in the position of n also I am substituting 1 by 2 minus 1 theta d theta. Clear? Next. So here 2 and 2 gets cancelled, here also 2 and 2 gets cancelled, 1 minus 1 is 0, here also 1 minus 1 is 0. So this becomes 2 times of integral 0 to pi by 2 sine to the power, 1 minus 1 is 0, right? 0 theta into cos to the power 0 theta d theta. Clear? What's next? Look at here, any number to the power 0 is equals to 1. Remember this, any number to the power 0 is equals to 1. To the power 0 is equals to 1. Therefore, even this goes to 0, this tends to 0. I'll write it here. This tends to 0 and this also tends, sorry. Any number to the power 0 is 1. So this goes to 1 and this also goes to 1. Clear? Therefore, here I can write it as 2 times of integral 0 to pi by 2 sine to the power 0 is given by 1 into, this also goes to 1, therefore d theta. So we are left over with 2 times of integral 0 to pi by 2, 1 into d theta is given by d theta. So if we don't have here anything, we can consider this has 1 here. 1 ones are 1, right? If there is nothing also, I'll consider here 1. How can we write this 1? Any number to the power 0 is 1, right? So here my variable is theta. I will consider this as 2 times of integral 0 to pi by 2. Instead of writing 1, I can write it as theta to the power 0. Theta to the power 0. Correct. So d theta. Instead of writing 1, right? 1 is nothing but indirectly any number to the power 0. So that any number I will consider here, theta is my variable for integration. So I will consider this as any number as my theta. So theta to the power 0, it becomes enough. So what happens here if we consider this integral 0 to pi by 2 theta to the power 0 d theta. So this is remembering one formula of the integration. What is that formula? Integral x to the power n dx is given by x to the power n plus 1 divided by n plus 1. So this is the integration formula we are using over here. So what happens to this? So this becomes our here n value is given by 0. Instead of x I am having theta, that's it. Formula is same, formula is resembling here. Instead of x I am having theta, instead of n I am having 0. So here we don't have the limits for the integral, here I am having the limits for the integral. So that is how we will be substituting here. Look at here, how do I do this? 2 times of integration of 0 to the power theta is given, can be considered as theta to the power n plus 1, that is 0 plus 1 divided by n plus 1 is nothing but 0 plus 1, and here we are having the limits. So how do we define the limits? Upper limit minus lower limit. So I will take this upper limit here and minus lower limit here. So we have already integrated with respect to theta, and this is our final output after integrating from the theta. But this is not our final required answer. We will continue this to get the required answer. Look at here. So what does this become? 2 times of theta, 0 plus 1 is 1. Theta to the power 1 is theta itself divided by 0 plus 1 is again 1. So this is having the limits of minus pi by 2, and here it is 0. How can I write this? First I have to substitute the upper limit minus the lower limit. So what is the variable I am having here? Theta. So 2 times of within the bracket theta I am having. For theta I have to substitute upper limit first minus lower limit is given by 0. Substitute in theta. Theta by 1 is nothing but theta itself. So I have not written here. Hope you understand this. So theta pi by 2 minus 0 is given by 2 times of this goes to pi by 2 itself again. So here for 2 and 2 gets cancelled, we are left over with pi. What is this? This is nothing but beta of 1 by 2, beta of 1 by 2 comma 1 by 2. So beta of 1 by 2 comma 1 by 2. I'll consider this as equation number 2. I'll consider this as equation number 2. Have a look at here. This is also beta of 1 by 2 comma 1 by 2. This is also beta of 1 by 2 comma 1 by 2. Now what can I do now? I can just equate equation number 2 and equation number 1. Instead of going to the next page, I will just cover up here itself. Kindly have a keen observation here. I am just taking out the line here. So beta of 1 by 2 comma 1 by 2 can be taken as what is this here? I'm having both the sides. I'm having beta of 1 by 2 1 by 2. Therefore I'm writing this one. So I'll just equate this. So what does this becomes? This becomes gamma of 1 by 2 the whole square is equals to pi. I have taken this also here and I have taken this also here, equated both the equations. So what does this becomes now? This becomes gamma of 1 by 2 is equals to, put the square towards the other side, it becomes square root. What was required? We required the same thing, that is gamma of 1 by 2 is equals to root pi. So that is what is here, gamma of 1 by 2 is equals to root pi. This is the required final output. I'll repeat it again, just listen. So to prove this proof, gamma of 1 by 2 is equals to root pi, initially we have to consider the relationship between the beta and the gamma function. Beta of m comma n is equals to gamma of m into gamma of n whole divided by gamma of m plus n. And next, since they have given here in the question, in the proof, that is 1 by 2 here, gamma of 1 by 2, I will substitute both m and n variable as 1 by 2 only. Okay, so if I substitute 1 by 2 here, beta of 1 by 2 comma 1 by 2 becomes, so in the position of m, take it as 1 by 2, position of n, consider it as n by 1 by 2. So substituting in this relation, so what happens here, in the numerator, both the terms are same, so this becomes a into a is a square. So therefore, this into this becomes this gamma of 1 by 2 the whole square. In the denominator, 1 by 2, half plus half is 1, gamma 1, we know that it is equals to 1. Therefore, I have taken here the numerator 1. Denominator 1, in the next place, in the next step, it gets dissolved. So we are left over with this is beta of 1 by 2 comma 1 by 2 becomes gamma 1 by 2 the whole square. I'll retain this as equation number 2 because I can't move it in a further steps. So I'll consider one more alternative formula for this beta function, that is given by beta of m comma n is given by 2 times of integral 0 to pi by 2 sine to the power 2m minus 1 theta into cos to the power 2n minus 1 theta d theta. So in the position of m and n, we have to just substitute 1 by 2. You have to remember two major formulas here. One is this relationship between beta and gamma function, and this alternative function of beta function, which is having in terms of sine and cos. I have to remember both the formulas. So here in the position of m and n, both the case you have to substitute 1 by 2 and 1 by 2. So what happens here, if we substitute m in the position of m 1 by 2, so this becomes 2 and 2 gets cancelled away here, 1 minus 1 is left over, 1 minus 1 is 0. So here again 2 by 2 gets cancelled, 1 minus 1 is left over, 1 minus 1 is 0. So any number to the power 0 is 1. Any number to the power 0 is 1. Apply this over here. So this both goes to 1. 1 ones are 1. So we are left over with 1 here. So any integration value, if we are having 1 over here, we will be considering it as any number to the power 0. Which variable we are having here? Theta. So I'll take that any number as theta here. Theta to the power 0. So this can be considered as integral x to the power n dx. So this is how it has been representing. So I am considering this formula here. Integral x to the power n dx is given by x to the power n plus 1 whole divided by n plus 1. Next case, I am applying this formula. In the position of n, substitute 0. In the position of x, take it as theta. That's it. Okay. After that, what we are doing? We are just doing some simplification over here, then substitute the limits. First you have to take up the upper limit, then minus lower limit. So this is what is given here. Next, 2 and 2 gets cancelled in the next step, and we are left over with pi. So here we got that beta of 1 by 2 comma 1 by 2 is given by pi. Further we can't take it over, but we got to know that this is also beta of 1 by 2 comma 1 by 2, and this equation is also representing beta of 1 by 2 comma 1 by 2. So from both the equation 1 and 2, I can just equate these two terms because our LHS is equal. Therefore, I am taking beta of 1 by 2 comma 1 by 2 is given by this gamma of 1 by 2 the whole square, and from here it is pi. Therefore, take out the square towards the other side, it becomes square root. So we got gamma of 1 by 2 is equals to root pi. This is how we will be solving this particular proof. It is very simple, and most frequently it will be asking, they will be asking in your exams. So now let us solve few problems on gamma function so that we will understand where to apply this particular formulas in which kind of problems. Okay, so look at here, I have considered one of the question here. Most of the question will be as similar to this itself. So these are the problems on the gamma function they have given here. They just give evaluate integral 0 to infinity x to the power 3 by 2 e power minus x dx. How do we consider which function it is, whether it is gamma function or beta function? So have a look here, you have to remember the formulas for everything. So just you have to give your keen observation. What does it happen here? Integral 0 to infinity. Integral 0 to infinity, it is there for gamma function. So we got to know that this is gamma function. Not only this, have a look here. Here we are having e terms and x terms. Yes, we do have x terms and e terms here, but that is just interchange, that's it. So e power minus x, e power minus x is available, x to the power n minus 1, x to the power 3 by 2. Instead of n minus 1, I am having 3 by 2. Correct? Therefore, the given question is resembling gamma function. So take out this formula here, substitute the things, and we have to use some properties here to find out the answer. Clear? So let us consider the formula first, then we will take up the further steps. Okay, so our formula is given by, we know that what we know? We know the formula. Formula is given by gamma of n is equals to integral 0 to infinity e power minus x into x to the power n minus 1 dx. X to the power n minus 1 dx. For finding out the gamma function, we don't know n. So now our task is to find out the n value. How do you find out the n value? Look at here. We have to just give our observation here. That's it. Nothing much. So what is not matching here? Look at here. E power minus x is matching. And integral 0 to infinity is matching. X is also matching. dx is also matching. 3 by 2 is here. N minus 1 is here. Therefore, I have to match this n minus 1 and this 3 by 2. What I will do here, I will consider n minus 1 is equals to 3 by 2. Okay, so what does this becomes here? So if I consider n by 2 is equal, n minus 1 is equals to 3 by 2, this becomes n is equals to 3 by 2 plus minus 1 going towards that side becomes plus. Then if I consider the LCM, 2 ones are 2, 3 plus 2 is 5. 5 divided by 2 is our n value. So n is given by 5 by 2. N is given by 5 by 2. Let me write this properly. So how can I write this? Integral. This question I will consider integral 0 to infinity x to the power 3 by 2 into e power minus x dx. This one I am writing in terms of 5 by 2. How do I write this in terms of 5 by 2? This is given by integral 0 to infinity. E power x is as it is. I will write e power x as minus x as it is. X to the power in the position of n, substitute 5 by 2 minus 1 dx. Done. So what is our gamma of n value? Gamma of n is nothing but 5 by 2. Gamma of n is 5 by 2. Clear? So how can I write this? We have to, instead of finding or integrating, actually we can just write gamma of 5 by 2. Gamma of 5 by 2. Correct? So now I have to find out the value for this gamma of 5 by 2. How do you find this? Very simple. Look at here. We know few properties here. What is the properties we know here? We know that gamma of n plus 1 is given as n gamma n. So look at here, we have so many properties. In this, which property you consider? When it is positive or some integer kind, we will be considering gamma of n plus 1. Okay, so I will consider here, considering gamma of gamma of n plus 1 can be considered as n times of gamma of n times of gamma of n. Correct? So how can I write this gamma of n plus 1? Here, just have a keen observation here. In the position of n plus 1, I will consider it as gamma of 3 by 2 plus 1. 3 by 2 plus 1. So here this becomes, what is our n value? 3 by 2 into gamma of n can be considered here as, at this particular position it is 3 by 2. It is 3 by 2. To find out the actual value of gamma, this particular given problem, I used this n minus 1. n minus 1 is equals to 3 by 2. Then I found out n value as fi by 2. But while applying this property, you have to be very careful. Whatever the value which was given in the question, that one itself we will be considering here, n value. Clear? Clear. So, to find out this part, to arrive at this part, to know gamma of phi by 2, I just use this n minus 1. But when you are applying the property, this is property, I will mention out here, this is property. When we are applying the property, at that case n value you have to consider which is given in the question. In question they gave it as 3 by 2. 3 by 2 plus 1 is obviously 5 by 2. Instead of writing 5 by 2, I am taking in terms of 3 by 2 plus 1. Okay, so why I am considering like this? If I do this integration, it takes pages to pages to give one single answer. But if I use this method, my answer will be getting in few minutes. Not even few minutes, few seconds I can say, if you understand this problem. Okay, so I am writing this 5 by 2 as 3 by 2 plus 1. So n, gamma of n can be taken as 3 by 2 times of gamma of 3 by 2. Clear? Again, I will use this formula again repeatedly. Repeatedly I will use. Instead of writing 3 by 2, I'll take this pink color pen itself. Look at here. 5 by 2, I represented it as 3 by 2 plus 1. Now, my task is this 3 by 2. This 3 by 2 is here. I am representing this 3 by 2 as 3 by 2 can be represented as 1 by 2 plus 1. How do you find this? If you don't know how to find out this, just take this number. Okay, I'll do in another pen. You can just have a look here. I'll do this in purple pen. Look at here. 3 by 2 I have here. Just subtract with minus 1. Okay, you will get to know what has to be added here. Purple pen I have marked here. Look at here. So what has to be added here, you will get to know if you just minus it from 1. So minus this, if you take LCM, this becomes over here 2. 3 minus 2 is 1, divided by 2 it becomes. Correct? So I got to know 1 by 2 here. So I can represent here as 3 by 2 into gamma of 3 by 2 can be written now as 1 by 2. I considered here it as, this became gamma of 3 by 2 plus 1. So 3 by 2 plus 1 is like this. Then next case it becomes, I will write this before going to the next step I will write, otherwise you will get confused, I know. Instead of writing gamma of 3 by 2, I will take it as gamma of n is nothing but 1 by 2 here, 1 by 2 plus 1. Directly eating, we are not doing that. Just coming from the backward side and towards the mouth. So that is what we are doing here. 3 by 2, I am considering it as 1 by 2 plus 1. That's it. Okay. So now you will be understanding. 3 by 2 can be written as, that is n plus 1. 1 by 2 plus 1 can be written as 1 by 2 into this gamma of 1 by 2. Correct? 1 by 2 into 3 by 2 is here. Don't forget to write it out. You have to write 3 by 2 also, and one more function you are having here. This is one more function. From that 1 by 2 is outside. Gamma of 1 by 2 is inside. Just now we proved a rule. What was that rule? That is nothing but we proved a rule. That rule says that gamma of 1 by 2 is given by square root of pi. So what can I do now? I can just write it here as 3 1s are 3, and in the denominator it is 2 2s are 4, and this gamma of 1 by 2 is nothing but square root pi. So what is the value? This is our final answer. I will repeat it again. Evaluate, integral 0 to infinity x to the power 3 by 2 e power minus x dx. Looking into the question, I just compared this with my formula. So my formula here only I have, no, I'll show it. So formula was saying that integral 0 to infinity was same, and x to the power n minus 1, in the position of n minus 1 there was 3 by 2, and e power x minus x was as it is, then dx. Correct. Next, everything was similar, only thing is in the position of 3 by 2 I had n minus 1. So I have to find here what is the n value, gamma n we require. So n we need to know, n minus 1 is given by 3 by 2, n is equals to 3 by 2, minus 1 goes towards that side, plus 1 it becomes n is equals to 5 by 2. Just for finding out gamma n, I used this trick. Okay, so here we got to know 5 by 2. You can just consider this as a trick. This part is just a trick. Clear? Next, now I am taking this as integral 0 to infinity. The question as it is I am considering, I am writing in terms of formula. What does the formula says? In the position of 3 by 2 I have to represent it as n minus 1. n minus 1 is nothing but 5 by 2 minus 1 if I represent. This is the same as it is. Okay, same thing, but writing in an indirect form. That's it. Next, this is eventually equal to gamma of n, but n value is given by 5 by 2, so therefore it is gamma of 5 by 2. Gamma of 5 by 2. This is how we got gamma of 5 by 2. Next, looking into this, we know this property. If you arrive at a particular problem, gamma of some fraction, use this formula property. It will be very simple to solve. So gamma of 5 by 2 I can write it as 5 by 2, I can represent it as 3 by 2 plus 1. Gamma of 3 by 2 plus 1 can be taken as 3 by 2 into gamma of 3 by 2. That is what is here. Again, this till you get some gamma of 1 and gamma of 1 by 2, you have to proceed forward. Gamma of 1 is 1, gamma of 1 by 2 is root pi. So your task becomes simple. So that is why I use this trick. Okay. So 3 by 2 I can represent it as 1 by 2 plus 1. So I took the same property here again. So I got the multiples here, extra multiples. 3 by 2 into 1 by 2 is nothing but 3 by 4. Gamma of 1 by 2 is nothing but root pi. Just now we proved it. Therefore, that is how we got this value. So I will give one problem for homework so that you will understand if you solve that problem. So evaluate gamma or integral 0 to infinity x to the power 5 by 2 into e power minus x dx. Okay, this is your homework problem. Kindly solve it and put your answers in comment box. Okay, so hope you like this class, understood this class. Okay, if you understood this class, kindly share it and give a thumbs up so that it encourages me to do more videos like such. Okay, kindly let me know your feedback in the comment box. Thank you for visiting Apurva'S mathematics class.